Greetings, ladies and gentlemen. In the previous video, we went over some of the methods of factoring as well as quadratic equations. Well, one of the methods included the greatest common factor method for factoring. And so in this video, we'll go into a little bit more detail regarding GCFs. And I will also introduce a new method called factoring by grouping. Okay. Now, let's talk a little bit more about GCFs. If we have a couple of numbers, let's say 10, 10, 15, 20, and 25. Now, the question here is, what is the greatest common factor for all of these numbers? Well, before going to greatest common factors, let's talk a little bit about what factors are. Well, factors are essentially numbers or terms that you can multiply together to get one specific number or term. Okay, let's explain that a little bit more. Now, for 10, if you multiply the numbers 5 and 2, you will end up getting 10. Therefore, both 5 and 2 are factors of 10. Alright, now let's also look at 10 and 1 as factors. For 15, the factors include 5 and 3, and 15 and 1. For 20, factors would include 5 and 4, 10 and 2, and 20 and 1. For 25 is 5 and 5, 25 and 1. Again, all of these are factors, what I just listed here, okay? Now, let's talk about common factors. Now, common factors are essentially the factors that are common in between all of these terms. So, let's see, do I have any factors over here that are the same throughout? I do. I have both 5 and 1. So 5 and 1, 5 and 1, 5 and 1, right? But when we talk about the GCF, we're talking about the greatest common factor. So you come to these factors, take the largest number from here, which happens to be 5 in this case, and write that as the GCF. Okay, so in this case, the GCF is 5. Now, this is an example of just with numbers. Now, let's get into variables a little bit. If we have, for example, I will write it a little bit over here, x squared, x cubed, and x to the 4th power. What are the factors of these? Well, x squared can be factored into x times x. In other words, if you multiply x's together, you will get x squared. X cubed is x times x times x. X to the 4th is x multiplied by itself. Well, it's x times x times x times x. It's essentially x 4 times. The greatest common factor. Okay, now do we have one x in all of these? Well, yes, we do. How about 2 x's? Because this one has 2 x's. And the answer is yes, of course we do have 2 x's in all of them. Let's just circle them. We have, well, let's underline. We have 2 x's here, over here, and over here. Therefore, what that means is that these 2 x's, or x times x, is the greatest common factor. So x times x gives us x squared. So our GCF equal to x squared. Now, the shortcut method of determining that is that the term, the variable with the smallest exponent will tend to be your greatest common factor. All right. Now let's combine both of these examples together and see what we can do. So if we have, let's see, 10x squared plus 15x cubed plus 20x to the 4th, and you are asked to pull out a greatest common factor from this. How would you go about doing that? Well, from these numbers, the idea is that first you pull out a greatest common factor from the numbers, and then you pull out a greatest common factor from the variable terms. From the numbers, 10, 15, and 20, it seems that, well, from before, that 5 is the greatest common factor. So what we will do, essentially, is divide out a 5 from all of the numbers. and let's put this in parentheses. All right. So if we divide 10 by 5, we'll end up getting 2. Right? I'm going to put a plus here, and there's a little space here, and afterwards you'll see exactly why there's a space there. But 15 divided by 5 will end up giving us 3, space, plus 20 divided by 5 will end up giving us 4. Now, let's look at the variable terms. Do we have a greatest common factor from them? Well, before we determined that, yes, we do have a greatest common factor from those variable terms, and that happened to be x squared. So what we will do is divide out an x squared from all of these, okay? So it would be x squared divided by x squared. I'll just actually write it right here. Anything divided by itself is simply 1. So we'll end up with 2 times 1. Now, we will have x cubed divided by x squared, okay? Now, x cubed divided by x squared, I will write that as well. Now, this ends up being, using rules of exponents, this ends up being actually first, because what I do is I subtract the 2 from the 3 when I'm dividing with the same basis. Now, if you have any questions about rules of exponents, please let us know in a message, and we will make a video answering just that. So this will give us 3x. Now, if we pull out an x squared, I'll actually write the x squared right there. If we pull out an x squared from this term, we'll end up with an x squared, right? Now, the idea is that if we look over here, this is the x to the 1 that we have here. Okay, that's that 1x. Then these two make up x squared, and that's this remaining x squared right here. So this is where the greatest common factor for numbers and variables comes together. And you will be seeing a lot of this in your algebra pre-calculus class, in your algebra classes pre-calculus, and even further into higher level mathematics. Now, let's do one more example of the greatest common factors before we get into grouping. And we'll erase all of this. Now, what if we had, let's see, x squared times x plus 3 plus 6 times x plus 3. Now, greatest common factor, again, is the largest term that you can divide out. The largest term that's the same between between various terms. In this case, you can see that x plus 3 occurs in both terms. So what we can do is we can divide it out or pull it out as a greatest common factor. If we pull out an x plus 3 from this term, well, that would essentially be dividing it out. Let's just take this extra step here. This is an intermediate step. So we divide x plus 3 out from here, just leaving us with x squared. Okay, so I will write that right here. I have an x plus 3 times, this leaves us with x squared, okay, because I just factored this out. We write our factors on the outside, or excuse me, separately. Now, we have an x plus 3 right here. When we pull that out, or divide it out, we are left with simply a 6. Okay. Now, this is another example of the greatest common factor. This actually example leads us straight into factoring by grouping, because factoring by grouping tells us that if we have something like, and now I will write this example right here, if we have something like x cubed plus 3x squared plus 6x plus 18, what we can end up doing is, well, this is 4 terms in this polynomial. In the previous video we saw that there were only 3 terms in our polynomials at the maximum. But this is a 3rd degree polynomial because we have a 3 over here. Now what we can do is we can group in parentheses the first 2 terms and group in parentheses our second 2 terms. So we will end up with this, okay? Now, what we can do is we can look at this term independently and see that the greatest common factor here seems to be x squared. Again, remember, the variable with the lowest degree or the lowest exponent should be your greatest common factor. So let's factor our x squared out. Okay? That leaves us with x squared times x plus 3. Alright? Plus, can we factor out anything from here? Well, it seems like 6 can go into itself once, and 6 can go into 18 3 times. Therefore, 6 is the greatest common factor. Okay? Now, if you're having some trouble visualizing that, I would recommend that you draw that you write 6 right here and write down the factors of 6. So that would be 3 and 2, 6 and 1, 18. The factors would be 9 and 2, 6 and 3. Let's see, 18 and 1. As you can see, 6 is the greatest common factor there. Anytime you're unsure, you should perhaps write up your factors. So let's divide that out, leaving us with x plus 3. All right? Now, if you can see here, this is just like this. Okay? Now, what I just did from the original polynomial, which was this without the parentheses, I factored it by grouping. Okay? And now the next step would be to see that x plus 3 is common in both. Let's pull that out, leaving us with x squared plus 6. Now that's an example of factoring by grouping. All right. Let's go over another example of factoring by grouping. And in essence, before we go over that, we should just realize that all that this is putting parentheses around the first 2 terms and the second 2 terms, and pulling out a greatest common factor, and continuing to pull out greatest common factors until you get to a point where you just can't do that anymore. All right? Now let's go over another example. All right. In this example, we have, well, 3x squared times x minus 1 minus 8 times 1 minus x. Well, right now it looks like we have, right now it looks as if this was already broken down into groups and factored, but we can still pull out something more, right? But it looks like we have an x minus 1 term over here, okay? And we have a 1 minus x term over there. So it seems like the only difference between this and this is that the x is negative over here and the 1 is negative over here, all right? So we can use a little trick to change that. We can write this as 3x squared times x minus 1 minus, all right, let's factor out a negative 1 from this. In other words, let's divide everything in here by a negative 1. So if we do that, then we end up dividing this 8 on the outside by negative 1. All right? And on the inside, we get negative 1 plus x. Okay? All I did here was I divided this by a negative 1. Multiplying or dividing by 1 does not change anything, okay, as far as values go. Multiplying and dividing by a negative 1 simply changes the signs, which is what we want, because now this looks very similar to this in terms of sign. We can still rewrite it though. We can have 3x squared times x minus 1. Now negative 8 divided by negative 1 will simply give us a positive 8. Rewriting this, we have a positive x over here, we have a negative 1. Okay. Now this looks very similar to the previous example that we did, because all of a sudden we now have a factor, a term that we can simply factor out. In this case, we can pull out an x minus 1, leaving us with, well, if we pull out an x minus 1 from here, 3x squared plus 8. Okay? Now that is another example of factoring by grouping, where our terms were already grouped. All that we had to do was change the signs by dividing out a negative. Now this is a fairly common occurrence, So you would certainly want to study this example a little bit more. Thank you for watching.